Good morning, Bronx Arts Middle School. Hi to all my seventh graders. Let's look at our science assignment for today, Tuesday, March 24th, 2020. Our goal is to identify chemical reactions. Happy Tuesday to everyone. It's also important that we know science standards and why we're learning certain things. So if you notice in the bottom right-hand corner, I did put the science standard in for today. It is matter and its interactions or chemical reactions. We will analyze and interpret data on the properties of substances before and after the substances interact to determine if a chemical reaction has occurred. Let's go to our next slide. That big number 7, there are 7 major signs that you can use to help you determine if a chemical reaction is taking place. It doesn't mean all 7 have to exist. One of the 7 can exist, or several out of the 7 can exist, but that will let you know if a chemical reaction has taken place. So we're about to watch a video, and if you see here, I put take notes as you watch the video. So you might want to watch that video twice. Watch it first through the first time without taking notes, and then watch it a second time and take notes so that you can get all 7. Let's watch the video.
The big thing to remember is that the atoms in a chemical reaction in those substances, they're rearranged, and we end up with very different substances. So the first sign of a chemical reaction, that's a change in temperature. Think of a candle burning. We say that this is exothermic, an exothermic reaction, because it gives off heat. Mixing an acid and a base, that also produces heat. These are signs of a chemical reaction taking place.
First sign is temperature.
The second indication of a chemical reaction is a change in color. Think about rusting or burning. The changes in color, they take place because the products of the chemical reaction, the things that are made, are very different from what we started with, the reactants. They're different chemically and they're different physically.
Second sign
Bubbles
is
also
color.
suggest that a chemical reaction is taking place, especially if you're not heating the substance. Be careful because boiling, that's not a chemical reaction, even though there are bubbles. It's still water before, during, and after boiling.
Bubbles can be a
The
sign.
formation of a precipitate is usually evidence of a chemical reaction. This happens when you mix 2 liquids together and a solid forms, and that solid, it falls to the bottom of the test tube. When you see a precipitate, you're pretty sure a chemical reaction took place. Another sign of a chemical reaction is when light is given off.
Light.
This happens frequently when we burn things, combustion. A change in smell can be evidence of a chemical reaction as well.
Smell or taste.
Taste too, I suppose, for all you kitchen chemists. A final important piece of evidence that a chemical reaction has occurred is that the change is difficult to reverse. Changing ashes back to paper, that's very difficult. Changing rust back to iron, again, that's pretty difficult. A physical change, like boiling water, that's easy to reverse. We just let the water cool and we have water again. Again, a big idea here is that we've created a new substance. The atoms have been rearranged in a chemical reaction, and we have new things. They have new chemical properties and new physical properties. This is Dr. B with 6 or 7 signs of a chemical reaction, and thanks for watching.
So our 7 signs, just to go over it again. Number 1 was temperature. Number 2 was color. Number 3 was bubbles. Bubbles don't always show that there was a chemical reaction, but that can be a sign. Precipitate was number 4. Light was number 5. 6 was smell and or taste. And number 7, it is difficult to reverse. Those are sure signs that a chemical reaction has taken place. So now let's look at the next slide, which talks about write about it. How can we test when a chemical reaction has occurred for substances? Explain your ideas. So you will see that assignment in a Google Doc. That's where you'll share your ideas and talk about the 7 signs that you just learned about and just jot it down in your notes. Digging deeper. Now that we understand what a chemical reaction is, and now that we've learned that making soap requires a chemical reaction, let's continue our lesson digging deeper and explore more on the facts about soap and learn more about the many ways of making soap. So this is taken directly from your workbook, lesson number 11, reading 1. Do people really make soap from fat? And that was taken from workbook pages 94 through 96. Don't worry about the workbook. Everything will be in Google Docs. So we're going to get ready. And we know that this shelving here looks familiar. This is the way we see our soap today in the supermarkets. You have learned a lot about substances and mixtures. Do you think that the soap you buy in the grocery store is usually a substance or a mixture? Give reasons for your response. You can jot that down in your notes, and you will definitely answer that question once you get to Google Docs. Today, most people buy soap at the store, but there was a time when people made their own soap. In the 17th and 18th centuries, people followed 3 steps to make soap. They made their own lye. That was the first step. Make a lye solution from wood ash and water. The second step was they prepared the fats. They had a unique way of figuring out how to prepare fats. And the third was they combined the fat and the lye, which is what we do today, and they heat them. Their situation was just different on the way that they made these substances. So we're going to watch a little video that shows us more of how it looked back in the 17th century. As you can see, it's a long process.
This is how we make soap in North Carolina, from scratch. First you catch a wild hog, cook it, render the fat, burn a few logs of oak,
And
sip the ashes.
We'll be able to take a shower.
Yeah.
25 minutes later, and she's still stirring.
Oh, cool.
This one is pumpkin spice with a mixture of normal oats and rolled oats. This one is allspice with mixed up with ground cinnamon, orange zest, whole cloves, an entire candy cane, snipped up rosemary, and 2 bags of peppermint tea.
These are just substances you can add to soap once it's mixed. It's not necessary, but she's just showing you different kinds of soap. Guess what? Can't leave until I finish my exit ticket. So now we're going to probably go back to Kahoot. We're going to talk about our exit ticket. In there, we're going to talk about what is the purpose of drain cleaners. So that takes us off topic slightly, but not so much. We'll see what the connection is after. Do you think drain cleaners have some of the same ingredients as soap? And what do you think drain cleaners might do to your skin or your clothes? So again, those questions are going to be in our Kahoot. They're multiple choice, and we will dig deeper into those questions after we finish. So let's go back to Kahoot. And then after Kahoot, it's now that you've learned a little more about chemical reactions and more about making soap, open the Google Doc and read the lesson on comparing colonist soap to the soap we use today. And if you guys have any questions, you already know Ms. Jones will be in the room at 10:30. I actually will be there a little bit early, 10:15, so that we can chat, hang out a little bit, answer any questions. And then you can also email me as well. Good luck, and I will talk to you guys soon. See you in the chat room in our Google Meet. Thank you.